Okay, welcome to Unit 2. Alright, this is going to be additional views. So we went over multi-view drawings, orthographic projections, but there's a lot more than just that, so that's what this unit's going to be about. From the previous units, we should know what our object lines, leader, dimension and extension lines, hidden lines, break lines, we should all know what those are. And then the multi-view drawings, right? Typically it's just the front, right side, and top view, unless more detail is needed, and it's used with orthographic projections to give more detail. Okay, so for this unit, we're going to try and identify the various additional views used in shop drawings. Relate the purpose of each of the various additional views used in those shop drawings, and interpret additional views for the information expressed in these drawings. So we'll just be given examples of a drawing for each of those views. And then correlate the information being conveyed in the additional views to the multi-view drawing of the part itself. Okay, so conventional breaks, remember those break lines from the previous unit, right? So this indicates a portion of the part that has been removed, all right, so that the remaining portion can be drawn to a larger scale. This just gives more detail that's relevant to the fabrication process, and that portion that's getting eliminated between those two break lines doesn't contain information that's important, so it's fine to be removed. Okay, this is also known as a partial view using conventional break lines, and this is not technically an additional view. So a break is kind of its own thing. All right, all these other things that we're going over, they're additional views, but a break is its own thing. All right, and then short breaks indicate a short distance left out of the drawing. So a conventional break can be fairly large, all right, but the short breaks are meant for just smaller sections, which you'll see right here. Okay, short break, okay, and it's kind of a squiggly, not straight, usually kind of slanted line versus a long break for a conventional break, right? It's got that kind of EKG heart monitor looking break to it or line to it, and that's denoting that there's a continuation of that part beyond those lines that we're removing to save space. And so you can see section AA. If you went to the break line right here, AA, and this is telling you this is the section that's going to be broken. Boom. Section AA, section BB, same thing right here. So we also have cylindrical breaks. Okay, so here's your break. Looks a little different. All right, it doesn't have that jagged line, doesn't have that EKG line. This looks more like a fish mouth you would see, or a saddle. Okay, so a cylindrical break. This is just a portion removed from any drawing of like pipe, round tubing, or round rod. Break lines the same width as the object lines and drawn curved to indicate that it is a cylinder. So that's why they do that kind of fish mouth cut through it. The section lines, remember what our section lines are. Turn on my laser. The section lines right here, so that denotes that there is a solid portion there, right? So they do this so that you can tell that this is a wall thickness, right? This isn't a solid piece, this isn't solid round bar, it's tubing, okay? And so they fill in the wall thickness with the section line so you get a visual representation of the wall thickness. You could also denote that this is pipe because you got that hidden line right there, okay? And that's, again, your ID, OD. So that hidden line is also telling you that this is pipe. Okay, so auxiliary views. These are used to show the true size and shape of a surface that is on a part that is bent or has an angle to it other than just vertical or horizontal planes. All right, and so this is just to give more visualization or more detail of a part that has an angle in it or a bend. So here's an example right here. You've got this part that gets a bend in it, and so an auxiliary view would kind of show extra detail on just the bent part. Okay, so rotated 90 degrees from the orthographic view that it is associated with, right? So right side view, the auxiliary view, whoop, 90 degrees off the side, and we're just detailing at this point the bent part. Okay, we got that break line right there. So the auxiliary views are more focused on just the angled or bent parts. And we've got our section views. So remember our section lines. It's all what gives us the like the cutting plane view. Section lines. These are additional views to an orthographic view at a given point along the part. Okay, so it'll make more sense when we show you the drawing in the next slide. This provides print reader with additional detail of the assembly or parts at the cutting plane line. Okay, the cutting plane line is drawn at a point of interest. So looking at this, uh, if we saw this on a drawing, kind of difficult to tell what exactly this is, right? This could be like a top view of a T-joint, okay? So we want more detail on what this is, what the shape or profile of this is. So you would do a cutting plane line, boom, boom, and do a section view. So you're going 90 degrees off and looking at this line right here, all right? So you're not, this does not tell you to actually cut the part, okay? So this is not a like a weld symbol or something where it's telling you what to do with the material. This is just to help visualize that section of the part, okay? So that's what a section view is. A developed view, okay? So these are meant more for parts that are getting bent. So if you need detail of the part before it's bent, you would use a developed view, okay? So this contains exact dimensions of a blank, so a blank is just a part that has not been processed yet. Before bending procedures take place, they can be one of the orthographic views or can be drawn as an additional view if you're in a sub-assembly print. And it'll have the location of the bend or break, and it'll be dimensioned with other features on the part as well, okay? So if we're looking at the part here, here it is unbent, flat, okay, with the detail of a couple slots and a hole. And then here it is bent, all right, bent. So a developed view is just kind of pre and post bending procedure. Okay, enlarged view, so pretty simple, pretty self-explanatory. An enlarged view, you're just kind of putting the telescope on it, or the magnifying glass telescope. So this is just a way to include extra detail or to enhance a detail of a part that might be small or difficult to notice. Typically drawn on a larger scale than the rest of the print. So the area needing clarification will be identified with a letter or number, often circled. As you will see in the next slide, the enlarged view will identify with the letter and number on the drawing. Okay, so kind of like those section lines or those cutting plane lines, you'll have a letter or a number, and then you'll go find that elsewhere on the print, and that will be the reference for your enlarged view. Like so. Okay, so you can see we've got two different drawings over here. We've got detail C and detail A. If you come over to the multi-view drawing, right, front view, right view. They didn't need the top view, so they omitted it. So it's just front view and right view. So if we look at detail A, find detail A, we can tell this is the enlarged view. So over here, you've seen a couple small tabs, boom. And now you can have a better visual reference. C over here is not an enlarged view. We've just got ourselves a welding symbol right here. So it looks the same on the print, okay, but these are just telling you to reference a different detail elsewhere on the print. But it's obvious that detail A is the enlarged view, and that's what it looks like, kind of a broken circle. Okay, so revolved views used with skewed parts. Okay, so attachments that are not typical or not symmetrical to other parts. So the true projection from the front view makes it difficult to accurately interpret the details, so that's when you would use a revolved view. This does make it appear shorter since it is at an angle instead of the same plane as the other parts. All the parts that are attached to a central point as if they're on the same plane, even if they're not, just to give more detail to the skewed part. Okay, so this is for like not symmetrical parts. Um, so this is what it looks like, right? This would be your, again, front view and top view, omitting the right or the left, top view, or I'm sorry, front view and top view. Okay, so we can see right here, this looks like just a straight line. We can't tell because from this view it just looks like a straight line, but when you throw it up into a revolve view, you can see what it looks like from the front view and the top view. So in the top view, you're actually seeing that there is an angle to this, whereas down here it just looks like a horizontal line. Okay, exploded views. So this is where when you get to like an assembly, which an assembly is just when you're putting all the parts together to a finished product. Okay, this is a spool adapter, so for a spool of wire, for like a flux core or a solid wire wire feeder system. And you can see we've got 3 parts here, part 1, 2, and 3, and this exploded view just shows you how those parts go together. All right, so really good if you've got a lot of small parts. You'll see a lot of exploded views in like assembly instructions, diagrams, manuals for certain equipment, things like that. And this just gives you a good reference of all the parts that go together and the kind of direction that they go together. This is also usually where you find references like you kind of see in here, where you can explode it and say, if you need to replace this fan, you know, boom, you could go reference number 2 in the book and it should give you like the part number and all that good stuff. So exploded view is very useful, very common. All right, so that's the end of this one. We'll see you guys in Unit 3.